We are talking about polynomials today. Poly means many, and that just means that you will have many terms. A general polynomial looks like this. This might look a little bit strange at the beginning, but I'm going to explain what this means. A sub n times x raised to the n plus a sub n minus 1 times x to the n minus 1 plus some more terms. I don't know exactly how many, but I'm counting down until I have a sub 1 times x to the n plus a sub 0. All right, what does this all mean? Let's have a look at it. So this number up front right here, this is just some number, and this is called the coefficient. The coefficient. And let's jump to the next one right here. All of this, everything between the addition signs, these are called terms. So each term has a coefficient. Now, because I do not know exactly how many terms I have, and in the alphabet we are restricted to a certain amount of letters, instead of using A, B, C, D, E, F, G, I am using a sub 1, a sub 2, a sub 3. So in other words, down here, these are little subscripts. And the last one that doesn't have any x anymore, that will be our constant. Just a number. Let me give you an example. For instance, 3x to the 5th plus 2x to the 4th minus 5x to the 3rd plus 2x squared minus 3x plus 10. So what we have right here is a polynomial with, let's see, how many terms do we have? 1, 2, 3, 4, 5, 6 terms. Now, what about coefficients? Coefficients are just the numbers that are in front of your x terms, of your x variables. So in other words, right here, there is a coefficient, a positive 3, a positive 2, a negative 5, a positive 2 again, a negative 3, and the last one is our constant, 10. Now, what was up here with this n's and n minus 1? Well, this is just going like this. The first one is the biggest one. In this case, that was 5. We also call this now the overall degree of the polynomial. This is the degree. It is degree. I can't write. Degree. The degree of your polynomial. It is the biggest exponent that you can find. All right. And what will be then the next bigger one? Well, 5 minus 1. 5 minus 2. 5 minus 3, 5 minus 4, and so on until you get to 5 minus 5, which would be 0. Let's go ahead and look what we are going to be doing with these polynomials. First, addition and subtraction. So the first thing that you're going to do, you open up the parentheses. After that, you combine like terms. Like terms are terms with the same variable and exponent. These are called like terms, and you combine those ones. It's like comparing apples and apples and bananas and bananas. Let's do an example. I want to add 9x cubed minus 11x squared plus 7x minus 17 to the first one, negative 7x cubed plus 6x squared minus 11x plus 13. This looks like a long problem. It is not. We can make this fairly simple. So, what was the first thing that I said we have to do? We are removing the parentheses. And because this right here is addition, nothing changes when I open up these parentheses right here. In other words, the signs all stay the same. So let me just write down this problem now without any parentheses. In my first polynomial, also there was basically a positive in front. Nothing happens when I open up the parentheses. I just get the exact same thing. Minus 11x plus 13. Now I open up the second pair of parentheses and I still have a positive 19x cubed, a negative 11x squared, a positive 7x minus 17. So the signs of the terms are all the same. But what I notice right now is that I have like terms. So in my second step now, I will combine like terms. In the book, they have written down all of the like terms next to each other. But I think it is easier if what we are just going to do, I'm just going to scan through it from left to right, starting with the first one. And now I'm going to look for a term that has also an x to the third. Can we find one? There is another one. So in other words, I have a negative 7x cubed plus 19x cubed. And if I combine these two like terms, all I have to do is I add or subtract the coefficient. So in other words, a negative 7 plus 19, that will give us a positive 12x cubed. Now I go to the next one, a positive 6x squared. Can we find another x squared term in this? Here is another one, a negative 11x squared. So I'm asking myself, what is a positive 6 minus 11? And that will give us, one moment, negative 5x squared. And I just proceed in this way until I have everything either underlined, or another way is to scratch the ones out that you are done with. And once everything is scratched out, you know that you are done. A negative 11x, there is another one with only one x, and that is a positive 7x. So I have a negative 11 plus 7, and that will be a negative 4x. I do not always have to have like terms. If there is just one term of it, then this is the one that I have to collect. But in this case, everything has a matching pair. A positive 13 minus 17. And that will give us then, well, negative 17 plus 13. That's a negative 4. And I am done. There is my solution. I have added both of these polynomials. Let's do one more example with subtraction. So here again, I have two polynomials that I want to subtract from each other. So my first step, as before, I will open up my parentheses. So in the first polynomial, it stays the same. Nothing changes on the inside. Now the second polynomial, the long one right here, because there is a negative sign in front, all of the signs of the inside terms are going to be switched around to its opposite. So the positive 10x cubed in here turns into a negative 10x cubed. The negative 5x squared will be a positive 5x squared, and I get a negative 7x and a positive 2. Think about that as if everything gets multiplied with a negative 1. All right, and again, as before, I'm combining like terms. This will be now my second step. I do not need to rewrite everything. It's already long enough as it is. Let's see, 10x cubed. There's a negative 10x cubed. Oh my goodness, those are completely canceling each other out. 10 minus 10 is 0. I have 0x cubes in my solution. That means they are gone. negative 8x squared, positive 5x squared. Let's have a look. Negative 8 plus 5, that would be a negative 3x squared. Remember, I did not need to write down 0 times x cubed. That will be 0. That goes away. All right, I've got the x squared terms. I go to the next one. Negative 5x minus 7x. So I have a negative 5 minus 7, and that will be a negative. Let's have a look. That will be a negative 12x. Done with those. And last but not least, a positive 6 and a positive 2. 6 plus 2 is 8. And just as before, I am done. Note something right here. When combining like terms, the exponents don't change. They don't change. You do not add up the exponents or anything. You leave the exponents alone. All right? That will come now when we multiply polynomials. So we have several rules. Let's have a look at the first one. This is called the product rule. If I have b raised to the m and multiply this with b raised to the n power, then what I do, I add the exponents. Here's a quick example. X squared times x to the third. Now that will be x raised to the 2 plus 3, which is x raised to the fifth. The power rule says if I have parentheses around 1 and I raise it to another exponent, so I have now two exponents right here. The one on the inside of the parentheses and the one on the outside. What I will have to do with these two exponents, we multiply these exponents. This one was addition on the top. On the bottom, I multiply the exponents. These are the rules that most of the time are getting mixed up. So if I have something like this, x squared, parentheses, raise everything to the third power, then what this is x raised to the 2 times 3. You multiply the exponents. And I get x raised to the sixth. Now, if I have more inside my parentheses, this is called the product to powers. If I have a product on the inside of my parentheses right here, this needs to be multiplication. Addition on the inside comes later. So if I have, like here, 2 times x to the fourth, all of this raised to the third power, then I have to be careful. This is 2 raised to the third power times x to the fourth raised to the third power. This first one is not going to be equal to 6. At that moment, you are doing a common mistake. 2 times 3 is 6, correct. But what you are supposed to do there is what is 2 raised to the third power. This right here means 2 times 2 times 2, 3 times, and that is 8. And I get x raised to the fourth, raise it to the third power. What I have to do is I have to multiply the exponents, not adding, and 4 times 3 will give us 12. All right. So these are the rules that you need to know and not mix them up. So let's have a look at one where we really need to be a little bit careful. A negative 4y squared raised to the third power. I am doing the same thing as before. What is this when I multiply this out? This was a negative 4 times y squared. So I have a negative 4, raise it to the third power, times y squared, raise it to the third power. Most of the errors are being done because students don't write down the problem correctly. A negative 4 raised to the third power. One moment, what is that? A negative 4 raised to the third. What does it mean? a negative 4 times a negative 4 times a negative 4. Now, a negative 4 times a negative 4, that is a positive 16. Multiply this one more time by a negative 4, and I will at first get a negative number, and it will be a negative 64. And y to the second, raise it to the third. In this case, we multiply the exponents, and overall we get a negative 64 times y raised to the sixth. So if I multiply monomials that have coefficients attached to them, then what I just simply do, I am multiplying the coefficients, and I look at the variables, and you will see. So what I'm going to be doing is I take my coefficients, I multiply these ones, and then strictly speaking, I have x squared times x to the seventh back here. This is all multiplication all the way through. And now I will just use the rules that we had for variables. 3 times 5, of course, stays just simply 15. And x to the second times x to the seventh is x to the 2 plus 7. And that will be x raised to the ninth. Okay, one more example. 6x to the fourth times a negative 3x to the third. I will do the exact same thing as before. 6 times a negative 3. X to the fourth times x to the third. This will give us a negative 3 times x times 6 will be a negative 18 times x raised to the 4 plus 3. And I'm ending up with negative 18 times x to the seventh. If I have more than just a monomial, monomial means one, mono means one, in this case for us polynomials, terms. If I have more than just one term, then what I will have to do in this case, I have a 6x squared, and I want to multiply it with 5x cubed minus 2x plus 3. I am using my distributive properties. That means 6x squared will get multiplied with each and one of these terms. So what I have here is I have 6x squared, and I have to multiply it with 5x cubed. I have a positive 6x squared times a negative 2x, so I am pulling that negative out up front from the negative 2x. I have a negative 6x squared times 2x. You see how the negative sign right here, this one right here, that was in front of the 2, this is multiplication, the overall product will be negative. So I just put it up front. And I have 6x squared times 3. And you see that these are now basically just 3 problems as we had them before. 2 monomials multiplied with each other 3 times. So now I'm just going to write down exactly what we are going to end up with. 6x squared times 5x cubed is 6 times 5. That will be 30. X squared times x to the third. I have to add my exponents. I get x to the fifth. Negative 6 times 2 is a negative 12 times x raised to the 2. Think about as if there is a x to the 1. So 2 plus 1, I have 3. Plus 3 times 6x squared, that will be 18x squared. All right, here's a look ahead, what we are going to remind us about in one of the next sections. This was multiplication. This goes from here to here. down to there. What we are going to be doing later is called factoring. And factoring is doing the exact same thing, just in reverse. I will start with something like this, and I will go backwards to receive something of this form. Multiplication versus factoring. Let's do 2 more examples. We are supposed to multiply 2 binomials. Binomials have exactly 2 terms. So what I'm going to be doing right here, I turn this again into 2 problems like we had before. So this is 5x times all of this plus 3 times all of this. I'm writing it down as 5x times 2x minus 7 plus 3 times 2x minus 7. And now again I have a problem as before. I will multiply this out. The first problem, I'm going to be using my distributive property, 5x times 2x, 5x times a negative 7. And over here, 3 times 2x plus 3 times a negative 7. What will this give us? I think we can do this in our head. 5x times 2x will be 10x squared. 5x times negative 7, that will be a negative 35x. 3 times 2x, that is a positive 6x. 3 times negative 7, that is a negative 21. Now, strictly speaking, I have multiplied this out, but what I always have to do, if I see like terms, I have to combine like terms. And I have 2 terms that are the same, that have the same amount of variables that are like terms, and that will be negative 35 plus 6x. So what is a negative 35 plus 6? That is a negative 29 minus 21, and that is then the final answer. All right, one last one, a longer one. 2x plus 3 times 3x squared minus 4x plus 1. I'm going to do the same thing as before. I'm going to say everything first gets multiplied by 2x. And then everything gets multiplied by 3. Now I'm going to use my distributive property. This 2x will be multiplied all the way through here. And here the 3 gets multiplied with each term on the right side like this. So what do we have? 2x times 3x squared. 2 times 3 is 6. X times x squared will be x cubed. 2x times a negative 4x. 2 times a negative 4 is negative 8. X times x is x squared. 2x times a positive 1. That's just 2x. The next one. 3 times 3x squared will be 9x squared. 3 times a negative 4x, that's a negative 12x plus 3 times 1. And again, with what we've started this whole section, combining like terms. 6x cubed, that's the only one that I have with an x to the third, so there is no like term for this one. Negative 8x squared, there's a positive 9x squared. So this one was the only one. I have a positive 1x squared. 1 doesn't need to be written down. This is plus x squared. Plus 2x minus 12x. That will combine to a negative 10x. And you see, don't forget the positive 3 back here. That is still there. And I have successfully multiplied out my 2 polynomials.